5-star hotels. So basically, the adaptive design or adaptive reuse we should accept rather than demolishing the structure. Next. So resilient materials actually we want to use just to sustainability, all those things. So these are all you know, durability, resistance, everything you know. Next. So now the main part of any building design or erection, you cannot design anything of your sweet will. You have to have a guideline to make any type of, whether it's a small building, large building, tall building, a group of houses. Though you have to have some setback rules, guideline for the climatic sustainability, everything is there in the National Building Code. So all the building rules in the city of India has come from the National Building Code. That is not the mandatory rules, it is a recommendation. You may change the rule according to the state's infrastructure. Next. So these are the basically our concept for my design. When I will show you my projects, do you have considered the basic concept of today's topic? That means all the adaptability, resilient material, at the same time the design criteria, that will be in all, we will show 7 of our project. It will not be repeat. I want to go the repetition. I will show somewhere the pressure of the wind, somewhere the temperature, somewhere the segregation of the garbages, like that. So these are the all things we need to know from the concept. Next. Now presenting my own case. These are the projects we have done. First of all, Greenfield City. It is in the Behala. Obidipta 2 for the Bengal Peerless on Eastern Bypass. The 42, the tallest tower of the city in Chaurangi. The Royal Ganges, it is coming up in the Bajbaj near the Ganges, on Ganges. KPC Tower is coming on the Eastern Bypass near the Ruby Hospital. And the carved, most signature tower, it will come on the Chaurangi. And Arbana is also one of the good projects, Arbana. Here actually the carve and the 42. Actually I am the joint architect with Hafiz contractor. All other projects are my design. So these are actually design development, everything done by us. So it is a joint architect. Now, start. See, this is Greenfield City. Basically, it is the government housing, joint sector company. You have to have the, out of 100 flats, HIG, MIG and LIG. You have to categorize, you have to segregate. As per the government norms, 50% of the number of flat will be HIG, 40 will be MIG and 10 will be LIG. So we have the conditions. And also we have to take the FSI as per the developer's choice. We have to take. So this is the Greenfield City. It is almost completed. 62 lakh square feet of construction in the Behala on 52 acre of land. What is the USP of this particular project? This is the multiple award-winning project. It is the mid-sector housing. So what we have done? First, orientation of the blocks. Orientation of blocks, if you see the master plan, I will show the orientation of blocks, generation of multiple green pockets to avoid the heat islands. Also, preservation of the water body over there. This is the main points for this project. Actually, all the climatic condition I will cover in my 7 projects. So different projects I will show you different. So this is the master plan. This is the from the Behala Chaurasta. This is the entry of the flat. And there will be 4-story building for the LIG, G plus 4-story building for the MIG, and G plus 12-story for the HIG. There are 105 blocks with all the facilities as the city development. It's a Greenfield City. So as per the norms, you have to have all the facilities, including there will be a police station, there will be a bank, there will be a post office. Everything has been catered. Now next. If you see this is the completed project, you see there are green spaces within the 4 or 5 blocks. That means this will be the nucleus part of the total project. To have the green, there will be central green. This is the central green. Here, totally 22% is the covered area. Entire green. So why? So in climatic condition, if you provide more green and water, it will serve your purpose of not going to too much of heat. So in that way, there will be MIG sector, and we have carefully placed all the block around the central green. You see, this is the central green. 5.5 acres of central green. The buildings surrounding the central green have got the vista and also have the entrance to the plot from every block of the buildings. Here, the salient feature of this particular project, for the benefit of the stakeholders over there are 2 separate sports stadium, football stadium, and also there are some basketball, tennis, and everything is there. For the purpose of this housing, we have done everything. So this is one of the good projects. And this is basically for the middle income sector group. Next. Huh? So you see what I am telling you, this is the vast open space. You see, this is the vast open space in the middle of the entire projects. So everyone is getting the view of the green, water body, etc. And it's basically this is particularly the nucleus of the total project. Next. Now I am coming to high-rise housing, Dept 2. This is the project for Bengal Greenfield, Bengal Peerless, just beside the Metro Cash and Carry on the Eastern Metropolitan Bypass. This is, at this point of time, it is the second tallest tower in the city of Kolkata. It is G+46, and there are some parking space inside the building. Salient feature of this project, we have gone for the high rise, but to comply the car parking. You all know that for any projects, if you want to increase the area of the project or the flat, you have to provide the car parking. That is the main challenge for this project. So high-rise building, at the same time, what we have done here, we have done the natural ventilation in all apartments. I'll show you the plan. It's the renewable materials. We have got the green building certification of the IGBC. And the recycled materials used here. Next. So see, this is basically EM bypass. This is going to Vaishnavghata, this is the Ruby. This is the part, this is why it is Dept 2, because there is Dept 1 also in the back, the old one. So we are doing this part only. This is the main road. This is the high rise, 2 high rises of G+45 and 46. And there are this is the HIG category. This is the MIG category, the LIG category. 32-storied, 28-storied. And here the challenges were the parking. So what we have done, you see, this is the parking space at the bottom of the entire project. It is on the podium. It is on the podium so that actually the parking of 6 layer, all independent parkings, no mechanical one. Over that, there are the projects. So it is also 16.5 lakh square feet of the projects. Here we have taken the natural ventilation. So I'm showing you. Yes, you see the plan. Basically, we have taken a square. We have scooped out this part. Why? To give the cross ventilation of each and every flat. If you just study the flat, these are all luxury 3-bedroom flat. 3 side open, all 3 side open. So this is actually getting the natural ventilation and air and light. That is the main criteria. We are not depending on the artificial light or also artificial ventilation is not required. And here we have used the some external wall as the renewable materials. So yes, these are the, what do you think? Actually, we are not allowed to cut the trees to waste the wood, but some woods, it has been manufactured in such a way that actually Forest Stewardship Council, FSC, they are giving you the permission to use the wood. So here, actually, we have used this particular from well-managed forest of a small community produce. So here we have used that particular material to get the IGBC rating. Next. This is the picture at the time of construction. You see the construction technique and everything. This is all at the time of construction we use this material. And for particular that, the project has used material with recycled content for 30% of the total construction material, as per the IGBC rating. So that's why we have got the gold, IGBC gold for this project. It's a very pertinent point to give you that this is the only, or that area has the gold, the green building. Next. Now I am coming to the 42. Here actually I will explain a little bit to you for some technology which has been taken here for this type of high-rise building. At this point of time, this is the tallest tower in the city of Kolkata. 250-meter height, G plus 62 floors, habitable, plus 3 service floor. Here actually I am showing this particular project as it is ultra high-rise building. Here actually, what is the basically necessity of this project? That this is there will be some service floor. I will explain why we are putting the service floor. Designed for the combating load, that means if counter the load of the wind pressure, we have to have the counterweight. And emergency escape planning, that is all architects know, that we have to have the fire tower nowadays. As per the National Building Code 2016, for any building above 45 meter, have to have one staircase with lift enclosed, that is called the fire tower, with some other accessories. Obviously, we have put over here. This is the 42 we are starting. No? No, no problem. No problem. I am not in a hurry. This. You just see, I am explaining the site. It is all known to you. This is the Chorongi Road. Rasa Street in the back. This is the actual area. Here, the flat area of each floor, one flat. One floor area is 8,500 square feet. That means a particular person has to have the one flat in each floor, 8,500. Requirement of car parking is 8. If you see 100 square meter per car, 850 means 8 cars. And if you put so much of car in the basement and also in the outer scape, so you cannot put the soft surface like the green. Also, you cannot achieve the total FSI. Then what we did here? We have taken the high rise like a slender one. This is the actual picture from the Brigade Parade Ground. So this is actually slim building. And the construction technique is nowadays this type of building cannot be on the column beam frame. Not possible. So this is actually, these are all my-one structure with the structural elements, shear wall system. If you go by the shear wall, you architects know and all the students should know that if you put the shear wall below the building, you cannot put the car parking in a proper way. You cannot put the car parking because the wall will be vertical or horizontal, x-axis and y-axis. It will actually hamper the driveway. Then actually what we did, we actually take the entire parking in a separate building. From the Chorongi, if you enter into the building, there is a 8-story building where actually we put all the cars. Above the car parking, we have put a 2-floor club. But actually the building, this is the building in a small footprint. But it is actually 65 story, 200 floor. And there will be, we are doing also another building here. I am doing that one, it is under construction. We call it the 42 Middleton. It is coming up. It's already 5 or 6 floors have gone. It is 54 story, it will come. But the footprint is less. But the challenge here is no other space but to have the podium like Obidipta. It has to be in the podium parking. The salient feature of this 42 is that, next, you see, this is the section, basically, elevation section. What is service floor? For any high-rise building or the skyscraper, say, here actually, in my opinion, what we are talking about, all the high-rise is over 40 story. So it is a signature tower. These are all over 40 story. So if you go up, you just consider that you can, what we are doing in the general house, 4 stories, 5 stories, 6 stories, we take the water from the water tank, pump it up to the top water tank level in the roof, and by gravity it comes down. And you consider if the height is going up and up, at the height of 250 meters, what will be the capacity of the pump to push the water up to that level? Impossible. So what we are doing here, we are putting, this is the service floor in between the flats. So for example, in the 19th floor, we have kept one service floor. It is basically for the water tank, MEP, HVAC, electrical, all the services will be over there with a proper height. Say for example, if I push the water from the ground to 19th floor, it's very easy. Very easy. So that is there. So reducing the pumping load, we can make the service floor over here. From 19th floor, the water will be pumped up to the 22nd floor. Then at the same thing, we are reducing the pumping capacity. Like that, it will go to the top floor from here to here. So this is the function of the service floor which is required for the tall tower in a smaller size of plot. Why? If you have the capacity of 10 lakh square feet of water required for the fire department, what will be the volume of the water tank? It will take half of your property. And then at that point of time, you cannot put the no green space for the PCB norms. In PCB, you have to have the 20% virgin green. It will not be over the basement. It will be on the virgin only. So keeping the FSI, keeping the green, keeping the car parking requirements, and keeping the setback. So it is judicial architect has to think very judicially how to tackle all those things. And developer will not leave you if you don't take the FSI. That you have to consider. So here, this is the final position of the 42. Now, here, more challenges is here during the Amphan. In Amphan, there is nothing has been destroyed, nothing has been changed, anything. What we have done in 42, we have got the 3 service floor over there. Also, we have placed one at the top of the house. We have placed the space for the liquid dumper tank. What is that? It is basically vertical cantilever. Say for example, if it's a cylinder built like this, our foundation is here. In case of Amphan, it will be soil like this. But it is a vertical cantilever. I actually studied this, but before designing this part, myself and Hafiz contractor, actually we studied this frequency, consult with the structural engineers, and also studied from the Taipei 101. Taipei 101, this is the same type of cylinder building, 101 floor. We studied this building along with the architects of the particular project, and we actually learned from him that this type of sway can be balanced by the top level pendulum of the heavyweight. So this is the metal ball in Taipei. This is the solid metal ball of 40-ton capacity. It is hanging from the center CG of this building. In case of sway, it will go reverse. I took that part the idea, but here we have done, there is a 2 lakh liter capacity tank at the top of 42 building. Half of that will be filled. In Amphan, nothing has happened. It is fraction of second, there will be a sway. But this water will be balance the inertia again. This is actually fact. So this type of thing, and you see this is due to slenderness of the building, these are the framework, structural framework. You see, because the moment the building is going up, the ratio with the width and the height, there is a slenderness ratio, you have to consider that part. So here actually you have considered everything. So building with the structural element, it has been like that. Next. Okay, next. So this is actually regarding 42. Achha. Now one more thing. What I actually intend to tell you that time, the fire tower. What is fire tower here? In case of fire, you have to take the staircase, all the lifts will be shut down. And in case of 40-story, 50-story building, the basic refuse platform, which is required by the law, from fire point of view, you have to put the refuse platform for residential building first at 24-meter level. Then every 15 meter you have to give so what happens, say for example 24 meter, 39 meter, 53 meter, my building is 250 meter. There is no ladder. There is no such ladder for the fire department in India. In Kolkata, the tallest part they can tackle is 70 meter. And my building is 250 meter. So what to do? So our fire consultant from Singapore, they have tackled everything within the structure. What they did, they have placed one staircase with a lift. This is called the fireman's lift. In case of fire, all these 4 lifts will be shut down, but that will be started by generator. So fire person will come from the outside, take the lift and go to any floor of the fire and take the person into this area. They will take you from here up to here. If they can take you here, you are totally safe. Because that lift will be operated in case of fire also by generator, and that is the fireman's lift. Basically, here what we require is, there are some public address system, some shaft, some ducts, and that is enclosed by the fire ratings wall of 4 hour. These are all 4-hour fire rating wall. So,
pressurization.
This is also the pressurization has to be there, because in this type of building has to be pressurized, the lobby and everything. So this is the salient features of 42. It is highly technical. I had to sat with all the consultants, the electrical, HVAC, sanitary, structural, because this is not the job of an architect independently. No architect can do independently this type of structure. You have to have the knowledge, you have to have the study, and you have to have the discussion with them to make this type of building. Okay? Now this is one of my projects coming up. This is actually the case study 4. It is called the Royal Ganges. I think you have seen in the board, newspaper or something, advertisement. This is also high-rise residential, but typically this is something different from the other residential projects. This is a sort of second house. Not basically it is in Boj, beside the river Ganges, here. So 470 meter of frontage in the Ganga, and we have taken 39 lakh square feet of the total construction. It is the dense high rise, but the basic feature is all the flats. All the flats are looking the overseas the Ganga view. All. There is no rear flat. All flat facing Ganga, all building facing Ganga. And design was like this in the from the Ganges. We need to leave some space as per the port trust rule. The first line will be the bungalow, low height. So bungalow will look the Ganga. Then the second level is the townhouse, the stilt. So above the bungalow, the evidence will look the Ganga. And then, so that means first level Ganga, second level, the next is the height. So one after another. So basically, dense housing, but flats are not so big because it will be almost the second house for the owners. So 3-bedroom, 2-bedroom flats and bungalows. So here actually I want to show you, this is another part. You see this is the river, this is the master plan. So these are, there is all the flats are showing this. Here I want to show you the as per the PCB, beside the Ganges, you have to keep the your soil, topsoil preservation. That is one of the rule of the PCB, environmental norms. Topsoil preservation and also erosion control. Because basically it is beside the Ganges, so we have to take care for the erosion of the intersite. So we have taken all those things over here, and also the design the PCB and all the statutory organization we have complied with. So this is the Royal Ganges. It is already, the bungalows are there, already the building is coming up. Royal Ganges, you see, we are here actually, here also, same thing as per the environmental norms. You have to have the 1% of the total load, connected load, as a solar panel. So here actually we have provided the solar panel in the top of the building, and also there are some panel which is actually 1%, and also we have taken all the areas as a green, the bottom part. Next. Just I want to show you for the students also that actually recycling of the rainwater harvesting. Rainwater harvesting nowadays mandatory for any environmental clearances. You can do for your own building also, that is up to you. But the rule is the rainwater from the roof, you have to take in a sump. You can take it to the other side for the road washing, greeneries, everything, or else you can take back to the roof by making some filtration. Here actually I've shown this is a simple part. It will go back to the own tank. So this is also taken care here. So we have done this part also to keep the water, just to not to depend on the groundwater and municipal water. Next. This is actually this is now the, in my opinion, this is a very prominent housing in the city of Kolkata, the Arbana. Arbana, basically the relevant aspect of this ultra high project. This is also G+45. This is the third tallest housing project in the city. First 42, then Obhijita 2, and then this one, 3. First phase has already been completed, and also it has been occupied. Second phase of 3 towers is coming up. It is under construction. So here actually in the climatic condition we have taken here to have a more green space. It is remarkable to tell you that out of 65 acres of land, we have kept 20% green.
25,
as per now.
25. More than 15 acres, 25% green.
25%.
Virgin green is 25.
But
so real green will
regulation
be like
regulation is actually 20%. We have kept 25%. So that is the, basically, if you enter into the project, lot of greens, which will actually, that particular segregation will be done for the green building, and so it is also a green building, but actually all greens beside the towers. From one tower to another tower is around 150 meters away. And rest is green. So this is actually one of the project where actually it will improve the air quality, it will improve the surroundings, and also reduce the heat component within the project. That is the necessity of that. Here, one more thing for our climatic issue, that is the waste segregation, which you will show here, and also the composter and compaction of the garbages. This is the basic master plan of the Arbana. This is the Chowbaga Road for the bypass. And there are actually, these are all 7 towers already been done. These 3 towers is now all under construction, almost in the finishing stage. And there are bungalow plots also. You see the green. You see the lot of greens here. Also the bungalow they are also given the bungalow with the condition that they cannot construct more than 40% of their land. That means there are another green of the bungalow plot also. Here actually what we are trying to, that microclimate control by the temperature control due to the greens, water body, everything is here. So this is the Arbana, and also in the new project, in the podium, in the new projects, we are not going to the basement. We are going to the podium level. Over the podium, there is also green. So we are taking the green in all the front. Next. This is the Arbana, we call it 2. This is the under construction. I am talking about the top of the podium level here, where actually we can give all the greens. Okay. This is the total aerial view of the Arbana.
Next. Waste. Waste segregation.
Okay. This is another thing I want to tell you. The waste segregation, actually here from the tower, there are 2 types of tower, G+40 and G+45. From each tower in the common lobby, we have actually placed here we have placed the garbage chute. That is 2, one is the actually recycle and one is the total waste. So that is there. We have already followed the wet and dry garbage chute for the waste segregation from the apartment source. After segregating, we are given to the composter and compactor. That is also everything within the property. Next. Now I will show 2 projects which is coming up. We have got the sanction from the municipality but not yet started. One is KPC Tower. After completion, it will be the second tallest because it is G+58, 202 meters. Basically, here actually I want to show you the strategic wind pressure and how to tackle. This is the Sachi Tower. This is the Imami. Beside that, this is the plot. This is the actually plot size. We are making the tower here, and all the parkings are in the basement and podium. There is no parking below the building. There is a lobby. So this is here basically, this is a slender tower again. In the slender tower, the wind pressure, just to break the wind pressure, what we have done, it is aerodynamic method. You see here, this particular face of the building is not in the same plane. It is not in the same plane. This particular facade of the front view, there are projected balcony here, and this part is the recess. So the total air coming from the outside thrust, it is basically, it breaks at the time of pushing the building. So there are undulating part, there are some recess and projection part, so it will actually reduce the velocity of the wind here. Also, we have given in the top some
Crown.
this is the crown by pipelines that is actually giving you the air will be flow from here. So this is actually basically the wind load we have taken into consideration. There is also a calculation for this type of building that what will be the width, thickness of the glass. You cannot put the same glass where you are putting the G+4, G+5, G+10. No. The moment the building height will increase, due to the air pressure, there is a calculation of that. Due to air pressure, the thickness of the glass in the window, also the frame will be changed. That calculation you have to take from the very inception of the project. Otherwise, there will be like the Amphan or something like that. In future, if there is any more, the window will be totally will break down. You see here, this is the calculation. You see the floor level G+4, G+12 like that up to 54. You see the wind speed. This is the wind speed, and this is the thickness of the glass. That means this type of building in the top thickness will be around 10 mm. 10 mm thick glass will be required in the top few floors.
Have you put any moss over there at the top of the building like the
Yes.
Here no, it is not. Here actually what happened?
Sir, you're talking about the tuned damper? Yes, it's always there. For any slender building,
No,
it's always there.
that is there. But I am not describing, again, that's the same thing. I am not repeating the same thing, but this type of building you have to have. Same thing. It is there. It is within this. It is there.
So there was actually interesting thing that happened during the 42. We actually didn't get to make the crown because of aviation rules. So here what we did is, here we have the height in hand,
Height,
2 meters.
in
So we can
1970
actually
that
hide
you have
the
kept the height
damper
also.
tank on top of the.
Top of the building and height. Next.
You'll see that's why the 42 looks like the top has been chopped off.
42 actually due to aviation you couldn't go up. Now it is coming to Calcutta, it is signature tower. It will be, I think it will be the talk of the town in next few weeks. It is coming up. This is actually, this particular part has been adopted by Hafiz contractor. I am working with him for this project. Yeah, I am working with Hafiz contractor for this project. We are the joint architects. So this is actually, see, here actually what happened, optimization of the space planning. Why? Basically, if it is a slender building, you have to optimize the space. Otherwise, you will not get the sufficient space for the vehicles, fire tender to move around. In this type of buildings, they may ask you 7 to 9 meter wide driveway around the building. Then you have to have the green. At the same time, developer will ask you to give the full FSI. So basic idea of this building is optimization in the buildings itself. Actually, basically, these are the buildings where it is called the concentrated development. That means within a small space, you are going up. And if you see the section, this is the building. This is the building on the Chorongi. This is the footprint only. So there is no space to put so much of parking. So we have to put the parking within the building itself. Next. The salient feature of this particular project, you see the section, this is the entire view of the building, but the salient feature is just, say for example, here the width of the side open space is 14 meters. Out of that, we have to keep the green, also the driveway and some parking. We have kept the cantilever. This is actually 7 meters. If you put the vertical from the here, totally gradually it is increasing up to top. And the cantilever is 7 meters. So this is the salient feature of this particular building. And also obviously, the floor plans will be changed in every floor. It will be increased by some square meter every floor. So this is actually the curve which is coming to Kolkata very near. Next.
Sir, 882 grey water resource consumption.
Actually, that is also same thing. Gravity resource. No, basically, what he wants to tell you, this type of building, just consider one thing. This is the ultra luxury segment. Huge rupees per square feet in the city. Maximum valuable land and also the valuable flat. So basically the owner of this flat, they will aspire for the better water supply, better connectivity of the electrical gadgets. They can enjoy the entire air condition from the day to night. So here the question of cross ventilation and air and light will not apply. Because after selling to the owner, they can do anything. They will ask for the best of the best gadgets for the electrical and the sanitary. So here actually, what we have done here, the parking, EV parking will be required, electrical. There will be the grey water recycling. There will be the free cooling system, energy efficient electrical, rainwater harvesting, solar power, everything they will require in this particular building because they are paying the cost for that. So we have to think of this type of building with all the amenities at the same time to comply the rules also. Next.
Last slide.
Now, you all architects know this is a very common thing, but for the students at least, you should know that designing of this tall structure, architects need to know the basic functions of structure, electrical, sanitary, HVAC, everything. Otherwise, we cannot talk to the other discipline or other engineers. So, you see, say for example, wind, solar, rainfall impact on the height. How to tackle you? You have to tackle, so you have to know the orientation. Now, there are facade consultants also. This type of building, the facade consultants are also here. They will give the input. So you need to know whether he is doing the right thing or not in your elevation. So this is particularly this thing for the students, that the concentrated heat load, you have to mitigate the heat load by putting the water around the building or the greeneries like that. So very simple thing, but you have to take care of all these things. Okay. Chalo. Thank you all.
Thank you, sir. A very insightful session for all of us. So, without wasting any other time, we would like to start our next session, panel discussion. So, I would request the session chair, Professor Poulumi Banerjee Das, to take over the stage. Thank you.
We are running a bit late. I'm sorry to all the panelists. So we'll start with Architect Amitabh Das' presentation. So he is Assistant Vice President of Architecture of Railways Infraverticals, ISRA India. Architect Das is a registered architect with over 28 years of experience in architecture domain. He has extensive experience in the design and management of architectural projects across a wide range of sectors that include conventional rail, metro rail, airport, stadium, health, retail, residential, commercial, and industrial projects. Architect thus possesses excellent practical, organizational, and communication skills. They have a they have a comprehensive understanding of built environment, habitable space, and production of architectural documents from DBR to GFCs. He can also resolve project construction issues. So I had been very fortunate at the very beginning of my career. I was working with Amita Bodha at Stoop, and that time, so while he is setting it up, let me share a story. So that time he used to be the principal architect, and he told me once, Polomi, তোমরা প্ল্যানার্সরা কি করো বলো তো? I only enjoy designing space, you know. And then one fine morning, I see that he is dealing transportation projects, which is a big part of planning. And I was surprised that one who is to say I enjoy designing spaces only has transformed into a planner. And now he says that yes, that has a bigger imprint on community. And we will obviously like to hear from him because he's heading the Sistra vertical of transportation planning and transportation planning infrastructure. And here he is for us. He will be presenting. Acha, 2 minutes is setting up the presentation. You've called someone? Okay. So if we talk about transit urbanism, we are urban transit, especially in Kolkata, is in a total chaotic situation. Though we have the highest footprint of public transport among all the metro cities, but still we are unable to manage our demand and supply at the same time. So let us see what our experts have to say. With smart city, we have someone who is working on smart city transport, Dr. Shubhendu Sheth. We have Dr. Krishanu Shatra also, who has worked intensively on transport sector. So we'll hear from them what is the solution they have for us.
এক্সটেনশন নাম দেখেছে হ্যাঁ তাহলে কপি করে দিন
হয়ে গেছে তাহলে ঠিক আছে এটা কি
আপনার এই রিমোটটা কাজ করছে
রিমোটটা কাজ করবে এটা দেখি কাজ করছে আমি সেটা দিয়ে দিই
হ্যাঁ ফুলস্ক্রিন মোডে দিয়ে
So, good afternoon, all boys and girls. First of all, I'll just good afternoon, all the boys and girls over here. I first take this opportunity to put my gratitude to Polomi over here. as the HOD of SNU, Architecture and School of Planning. And I also thank other panelists over here. I'll just take this opportunity to talk on a topic which is today the transit urbanism. Frankly speaking, this is not a very easy topic. This is a very heavy topic. But I'll try to keep this interesting for all of you and put forward some of the example over here. And not only that, there will be lots of jargon over here also. I'll try to explain this thing in simplistic manner. Now, to go ahead, to give the introduction on the urban transit urbanism. Then what is transit urbanism? The transit urbanism is basically which that integrates the sustainability, the mobility, and the inclusivity to transform into a better urban planning or transform into a better city. Now these three words, sustainability, mobility, and inclusivity, these are itself a very big term, frankly speaking. Now sustainability means over here the sustainable transportation. The mobility over here is the transport mobility. Now what is the transport mobility? There are different kinds of transport mobility if we define it. So later on, we'll be just describing all these things. Now, what is the inclusivity? The inclusivity is in terms of the social equity, the climate resilience, the transit-oriented development, the multimodal integration. These are many, many things which basically defines inclusivity. And that is why I told you that this sustainability, mobility, and inclusivity itself are very big term. Anyway, then going ahead, what are the principles of transit urbanism? That is what I just told you, that the sustainable mobility, the TOD, what is TOD? Transit-oriented development, and the multimodal integration transportation. These three are the main and the basic principle of transit urbanism. And as I told you just right now, that transit urbanism also focuses on the social equality and the climate. Then what is social equity? You know, there are different layers of public passenger in the society, from the elite class to the mass. Now, generally, the elite class prefer to use their own transportation. But when it comes about the public transport, which basically gives the access to all the layers of the public, from the elite class to the mass people. And that is why the social equity comes into the picture. And what about the climate consciousness? The climate consciousness is basically the transit which catered to the reduction in carbon emission, which enhance the environment. That is how the transport become the climate conscious. Now, ultimately, what is the achievement in this particular transit urbanism? Actually, then it basically tackles the congestion, the pollution, the inequity, and the climate vulnerability in the cities. So these are the definition of transit urbanism. Now just in the first slide, what I told you, the basic principles or the core principles of transit urbanism. The first comes over here, the sustainable mobility solution. Now, what are the modes of sustainable mobility? First of all, the public transit, then the cycling, then the walking. These are, frankly speaking, the key low carbon modes of the sustainable mobility. Now over here, what is the public transit which is sustainable? If, as on today, globally, we consider, we can see that out of the global carbon emission, transport sector is liable or responsible for the 25% of global carbon emission. So, the public transit, which basically uses the energy in terms of electricity or hydrogen or other medium which emits lower carbon into the atmosphere, those are called the public transit or the sustainable public transit. And about the cycling or the bicycling, that is, all of us know that that is another mode of sustainable mobility solution. And nowadays, many a city, many a local bodies are encouraging the footpath, the walkable solution to the commuters, which is also a mode of sustainable mobility. Now, as I told, that electric and the hydrogen vehicles. Now, this is the talk of the town right now. All of us know that till now, majority of the vehicles use the carbon, or rather the fossil fuel, which is the petrol and the diesel. Gradually, we are moving into the direction of EV. And not only that, we are also exploring the other modes of transportation, which is hydrogen. I do not know if any of you know or not, Railway Board, Government of India is now experimenting a hydrogen rail in Chennai, which will be in operation very soon, in a trial mode to see its success. And that is how we are progressing in terms of the hydrogen powered vehicle. And another mode of the sustainable mobility is the shared service. If I say about the shared service, what is shared service? The shared service is that in India, many of us, or rather almost of us, use our own vehicle to go to the offices or for any other purposes. But if we basically share our own car with the other commuters, actually what will happen? It will basically decreases the use of the cars or the vehicles, and ultimately it will reduces the carbon emission. That is called the shared services. And to be frankly speaking, nowadays, many a city in the policy level, they are implementing or trying to implement these shared services. In Delhi, it is in experiment stage, and they are in the mode of doing these policy level changes to make the shared service a necessity, a preferred mode of transportation. And not only that, out of India, if we know about Singapore, in Singapore, it's a policy level decision mandatory for all the commuters who travel to office to take the other commuters also in their vehicle. So this is nowadays, or basically in future, that will be mandatory things to follow. Then another core principle of transit urbanism is the multimodal integration transport system. What is the interesting part of this multimodal integration over here? Have you heard about the unified ticketing system? I'm not very sure about all of you. But unified ticketing system is a need of the hour, And nowadays, many metros are trying to implement this process. Then what is this unified ticketing system? If I talk about the Delhi Metro, which is DMRC. In DMRC, the total metro line is more than 350 kilometers. And there are different routes, almost 13 or 14 routes. So by unified ticketing system, any passenger from any station can reach its destination point with a single ticketing system. Not only that, they are trying to implement this unified ticketing system in the government vehicles, buses also, so that with a single unified ticketing system, the passenger from any point can reach to his destination at ease. And that will give the commuters a great comfort. That is called the transit urbanism. The next point in multimodal integration, the last mile connectivity. What is last mile connectivity? What is called last mile? The last mile, when basically a passenger or a commuter walks out of his home, go to the office and comes back his home. So from the transit node point or the station, when he reaches his home, that is called the last mile. So that last mile connectivity has now very important for the transit urbanism. So what are the modes of this last mile connectivity? Nowadays, most of the metro, the bodies, the client, are incorporating the e-rickshaws, e-scooters, then the bicycles, and the pedestrian-friendly footpath as a mode of last mile connectivity. Another point in the multimodal integration is the digital traffic management. In the digital traffic management, nowadays the smart sensors or AI-driven traffic system optimize the flow and reduce the urban congestion. So when we talk about the digital traffic management, what comes in our vision? The vision comes about the signal point where the red signal, the green signal, and this signal. So once basically the smart sensors and the AI-driven traffic system comes into the picture, they can easily identify the congestion zone and accordingly a dynamic, the signaling system comes into the picture and that controls the total traffic. That is how nowadays many cities are thinking about. And it is not only about the road traffic I am talking about. In the railways also, in the metros also, these kind of smart sensors are coming into the picture. In railway, I do not know if you have heard the name of CBTC. System are now being implemented. What is CBTC? This is kind of a signaling system that is being now incorporated to make the rolling stock or in metros. In metros, the train are basically called the rolling stock. The rolling stock is being controlled in a better fashion so that the frequency of the metro rolling stocks coming into the platform are being increased. Nowadays, we can see that within 2.5 minutes of time, within 3 minutes of time, new rolling stock comes into the platform. So that CBTC system is so advanced right now from the conventional signaling system that basically enhancing the transit urbanism. Now, I'll talk about the TOD. The TOD is the transit-oriented development. The transit-oriented development has become very much essential part of transit urbanism. So there are 2-3 components over here. The most important component over here is the compact mixed-use development. So, if we use the transport nodes or the stations for the purpose of this compact mixed-use development or within the vicinity or nearby the transport nodes, it basically gives a compact kind of urban development, the urban planning. And it basically reduce the travel distance and improve the accessibility also. Then what are the other point of the TOD? The walkable neighborhood. So if the urban planners make a shaded pathway of vibrant public spaces to create a highly walkable neighborhood, then also it is creating a better city life for the commuters. That is also part of, transit-oriented development. And another is the housing, affordable housing solution. So if we, as an urban planner, if we make the zoning in that way, that we keep the housing sector, the housing zoning within the reach of the transit nodes or the stations, so it will ultimately improve the life of every commuters who stays within this residential or the housing zone and approaches these transport nodes.
10 minutes more, okay. Sorry to interrupt, but we have to finish within time or...
I'll take 10 to 15 minutes, not more than that.
Okay, thank you.
So, what are the interlinkages and the technological approaches about this transit urbanism? The smart mobility platform, I'll try to be very fast. Follow me. The predictive analysis. The predictive analytics, the sensor and AI-based platform uses predictive analysis forecast regarding the travel demand, improving the route optimization, and reducing the congestion. So, nowadays, most of the metro bodies abroad, not in India, we have not started yet, frankly speaking, they are using this sensor and the AI-based platform to check the footfall, particularly in the platform. And they see the demand, the public demand particularly, and that is how the travel demand is being calculated and the frequency of the metro coming into the station are governed. These are, in that high-tech, we are gradually going. Now, what is the dynamic pricing? Dynamic pricing, I hope you have already heard, because in railway, it has already come into the picture.
In flights also, everybody knows what is dynamic pricing
Exactly.
now. Yeah.
So, it is, nowadays, it is very much happening
Demand-based pricing.
Yeah. So, dynamic pricing is such thing which basically encourage the, and which, detect the peak hour. And accordingly, the pricing is being escalated, and then a non-peak hour, the pricing is being decreased. So, it basically encourages and gives the freedom to the each and every commuter to plan his travel at the off-peak time so that the pricing can be reduced and he can have a better travel. Now the next point is mobility as a service, which we call in our industry MaaS. Mobility as a service. It's a very big term. And it is the future of transit urbanism. Now what is this mobility as a service or MaaS? It integrates the trip planning, which I have already told you, the trip planning, the booking, the payment across various transport nodes for seamless user experience. It is the future, mobility as a service or the MaaS. Then the next point I'll cover is the data-driven planning and the behavioral nudges. Now, in in the transit urbanism, there are two critical things which basically guides this, which will rather guide this transit urbanism. One is GIS mapping and big data. The GIS mapping combined with the big data analyzes, what is analyzes? It integrates the massive real-time spatial data set from the IoT, the satellites, into an interactive visual maps to reveal real-time traffic monitoring, optimizing routes, etc. The best example, I hope all of you know, Google Map. I hope all of us over here use the Google Map. In Google Map, when basically you plan a travel, you can see that where is the congestion. So you can set your travel route accordingly. And that is how GIS map with big data nowadays are playing its role into this transit urbanism. Now, the next point in transit urbanism is the digital twin simulation. Now, what is digital twin? Have you heard the name of digital twin over here?
Yes, yes, they had workshop on digital twins.
Oh, that's
so
great.
please, those who had attended the workshop, can you please tell what are digital twins? Who all attended the workshop? Can I? Yes, I can see Intikab's hand. I think that's Intikab. What is digital twin? Please.
No, don't rack. I will try to give the emphasis on digital twin. There is a particular purpose. That is why I just asked this question.
So basically, digital twin is like, we can see a building information modeling, like a replica which is to be built at the real form. So first of all, we build that virtual scenario, 100% accurate to the real building should be in the real.
Thank you. Big
And
thumbs
it,
up.
yes, and it has layers also where you can see how it will change with time or some changes.
Exactly.
So,
Now,
yes.
Polome, I will cover that particularly. Now, that what is now the digital twin? Digital twin is the virtual model and the replica of the existing asset or the real asset which is already existing at ground. That is how it is called the digital twin of the real asset. Now, how this digital twin is being created? I hope you have heard 3D. I hope all of you have heard the 3D because almost all of you are now using either Revit or 3D Max or any other software to make a 3D model. Now, what is 3D model? 3D model is the generation of geometry. Nothing else, not more than that. In 3 dimensions, we create the 3D. Now, there are other layers also, like 4D, 5D, 6D, 7D. Do you know what is this 4D, 5D, 6D, and 7D? No, I suppose all of you are not aware. Now, when we add the time and the scheduling in that 3D model, it is called 4D. Now, again on 4D, when we add or the tag the cost part, it becomes 5D. Then when we basically simulate or calculate the energy in that model, then it is called 6D. And when in 6D, we put the asset management for the purpose of maintenance and the maintenance or the maintenance management, it calls 7D. When these layers of information are being put on the 3D, then it becomes the digital twin. And what it helps? It helps in analyzing the building in the digital form, in the simulation form, so that you can predict, or rather the digital twin can predict the behavior of failure, of the structural failure, of the maintenance need. So there are different needs basically which can be taken care of by the digital twin. Now, you will ask that for each and every project that the digital twin is required. No. Digital twins are required for very big infrastructure projects where humanly it is very difficult to predict or oversee what is going to happen in near future. Like Burj Khalifa. You know, digital twin is there. So in our transit sector also, we are gradually coming into that direction in India. In foreign countries, many projects are being developed in digital twin. In India, we still are at the level of 5D, 4D and 5D, not 6D and 7D. We do not simulate the energy simulation in the model. We do not do the asset management till now. But this is the future. Now the global case studies. I'll bit fast over here. Then Hong Kong and Curitiba. In Hong Kong, that MTR, the mass MRT, the mass rapid transit, integrates the high density mixed use development, or rather the TOD, around its transit hub to make it a very successful venture. And what it helps, it is helping the car use and enhancing the neighborhood vibrancy, and also it helps in reducing the carbon footprint. Now in Curitiba, there is a bus rapid transit system. We call it BRT. That also basically using the land use planning and boosting the ridership and lowering the emission. Now, both cities shows that how the TOD principles can improve the urban mobility. There are another two examples of Copenhagen and Arlington. In Copenhagen, if you do not know, I can tell you that at the government level, they are spending like hell. That 50% are budget going, the transport budget is going to invest into the cycling infrastructure. And they are encouraging. And in Arlington, again, it is about the successful implementation of transit-oriented development. I just want to add about the Delhi Metro expansion over here. In Delhi Metro network, we are improving in the last mile connectivity right now. Now by this transit urbanism, what is the policy recommendation and the conclusion? In the policies are being recommended to integrate the land use planning with the mobility strategies to prevent the urban sprawl and reduce the emissions effectively. This is the number one recommendation from planners' point of view, from the consultants' point of view, from the private sector point of view. Because unless or otherwise, we integrate the land use planning, it's very difficult to achieve this transit urbanism. The second important recommendation is the public-private partnership. What is this public-private partnership? It is the collaboration between the government sector and the private sector, which is, we call it is a PPP model. And that is the need of the hour. Because without big investment, this big infrastructure in the transit industry, it is very difficult. And apart from that, there will be a regulatory mechanism. The regulations are required to enforce low emission zones, set performance benchmark, and ensure safety and inclusivity compliance. So how it is important? Now talk about, we all know that in most of the metro cities, how important it is about the AQI, the air quality, or the carbon emission. In Delhi, if you know, from the government level also, from the Supreme Court also, the rules are being implemented purely on the Delhi to set as a low emission zone. And there are different policy levels are being implemented at Delhi to make it a low carbon zone. Now, what are the conclusion? The conclusion is that harmonizing mobility and sustainability, collaborative urban development, and technologically advanced expansion. I'll not talk more about it because I am just concluding over here. And now I'll just talk 2-3 points over here and conclude my session. As an architect, where do you find yourself in this transit urbanism? I hope
This is for audience to answer. He has thrown that question to audience. Please raise your hand and answer. Do you see yourself anywhere in transit urbanism?
No, where can, as an architect, you
can contribute, actually.
Yeah, you can
the
contribute.
arenas you can contribute. Yes. We have heard from Intikab once. Intikab only wants to contribute. That is not done. Yes, Sharbojit. বসে বসে হাসলে হবে না. Please, answer. Yesterday, what did you learn from entrepreneurship program? You have to make yourself seen. নিজের ঢাক নিজে পেটাতে হয়, এই যে এত শেখানো হলো, কি হলো তাহলে?
There are 2-3 fields or the sector where as an architect you can penetrate. First, I have told about the zoning. So as an urban planner or an urban designer, you can contribute into the development of this zoning. This is point number 1. Point number 2, as an architect, I have mentioned about the digital twin. I have not shown any planning over here because that was not my intention. Because I just wanted to focus what is actually transit urbanism. As an architect, you can plan MRTs, LRTs, different kind of transit system. And once that is developed, we can create 4D, 5D, 6D, and 7D, and we can create the digital twin. That is how, as an architect, you can contribute in this transit urbanism. And frankly speaking, if I remove the word urbanism, in the transportation sector, as an architect, you can plan the major infrastructure projects like metros, railway stations, airports. All these comes under the transportation industry, transportation infrastructure. You have to dream big. So I am representing Sister over here, which is a global MNC, and in the transportation sector, in globally they are position number 2. And above us, there is only one organization, which is ACOM. If I tell all of you over here about these big infrastructure consultants, there are many. There is WSP, there is ACOM, there is Sistra, there is the DP consultant from Germany, there is Aegis. So different global multinational companies are over here in India who are contributing to the infrastructure project designing and consultancy. You can see yourself there as an architect contributing to this transportation sector. My main purpose over here is to just letting you know that this domain is also there to contribute as an architect. I hope my session was interesting to all of you. Thank you.
Thank you, Mamtabada. Our next speaker in the panel is Mr. Shubhendu Sheth. He has 35 years of experience in transportation engineering, planning, and road safety studies. He has worked in several countries, including India, Bangladesh, Sri Lanka, Kenya, Uganda, Timor-Leste, Sierra Leone, Papua New Guinea, USA, and UK. He has experience of working on projects funded by the ADB, that is the Asian Development Bank, the African Development Bank, and World Bank, Zika, GIZ, and EU. He has master's degree in civil engineering, that is transportation department from the University of Texas, USA, and bachelor degree in civil engineering from JU. He is a professional engineer and a chartered engineer in India. He was a professional engineer and a certified planner in USA. He is a member of several professional institutes in India, USA, and UK. Mr. Sheth has worked in multiple organizations over 25 years, including Jacobs, CES, L&T, Rebol, Stoop, Jameson Mori, and Caltrans. In the last 10 years, he has been working as independent consultant. Mr. Sheth, the mic is all yours. You can just start your.
Hello. Good afternoon, everybody, and thank you for the kind introduction. My topic today is mobility and urban form. And I'm sorry, some of the things will be repetitions of what my previous speaker said, because I wasn't sure of what the other speakers are going to talk about, but I'll try to skip all those very detailed parts when I say it's repetition. First of all, I want to start with some of these definitions. Mobility, accessibility, connectivity, MSC. We hear about this quite a lot. But what exactly are those? And how are they different, or how are they similar? Now, mobility is, first of all, the ability to move. That is the ease of travel. How easily one can move, that's mobility. Accessibility is the ability to reach the destinations. Whenever we are trying to go somewhere, we have a destination in mind, and how easily we can reach that. That is defined by accessibility. And connectivity is a network that lets us move and lets us reach the destination. So these are very important concepts. In my presentation, I'll be referring to these words quite often. And they are also dependent on each other, interconnected. So what are the issues today? We have heard the issues earlier in earlier lectures also. One is about the issue of concern over climate change and the various extreme events that have happened. We have seen the flooding recently in Kolkata in September. And there's always a concern of rising fuel prices, traffic congestion, social exclusion, that also we heard a little while ago, increased travel time, poor air quality, increase in the number of accidents, road crashes. And we always need to have better accessibility, and multimodal transport is very important these days. This also we have heard about. And what is the scenario now in terms of mobility? All the emerging economies have now giving priority to, or have been giving priority to motorized transport for the several years, and we still are doing that. And cities developing, both in developing countries and developed countries are experiencing fast uncontrolled growth to the peripheries. This is everywhere. And this is leading to a wide variety of urban forms, and land use and transport are not properly linked, and therefore they're not giving rise to efficient mobility. These are the scenarios overall. We have also heard about urban sprawl, the spread of cities far away from the city centers, and this gives a lot of, this creates a burden on the municipal corporations who provide services in terms of public services, roads, water supply, sewer, and so on. Oh, shona jacche na, okay. And the urban sprawl also creates physical separation in terms of access of people to schools, hospitals, and other workplaces, because our nature of development is segregated. I'll talk about this in a little while. Now, how is it in India? Indian scenarios also, we have seeing cities are witnessing accelerated transformation from agricultural land to residential, commercial, office spaces, and these are growing on the peripheries. This has led to marked increase in traffic congestion. We have to make long travel, and this raises the question of traffic congestion, air pollution, demand for road. We always want more flyovers, widening of roads, because our travel are mostly road-driven. Most public policies also encourage urban sprawl. I'll come to this in a minute, why I said so. Because most organizations they want to decongest the central part. The central part is old, cannot have too much of capacity, so they encourage development in the outskirts, which in turn leads to more of urban sprawls, and in turn leads to more of travel. So what could be the solution to this? It can be achieved by designing compact cities. With the mixed use, this I heard from my previous speaker, with mixed land use development, more sustainable urban form, and this will help in reducing the distances that are needed to travel. It will help in lowering the emission and fuel consumption, reduce travel cost, and also improve the quality of life. These are overall solutions. But now looking at it specifically, how do we improve accessibility? When we are designing neighborhoods in cities and regions, we can reduce and we can encourage reduction in use of private cars, because in order to promote healthier living, more sustainable forms are necessary. And if we reduce the travel time and use of private cars, we can achieve that. Encourage active mobility by encouraging people to use walking as a mode. People have always used walking as a mode of transport. That's the most easy thing to do. And if we have designed the neighborhoods in such a way that it's easy to walk or to cycle and prepare infrastructure for that, then people will be more encouraged to use those facilities. And so creating urban form that is environmentally sustainable, socially equitable, and inclusive. We have heard this also from our previous speaker. Now, decentralization, car dependence, and travel. Now, this has happened over the last 40 years or so. This is basically a dispersal of growth from the urban centers, and this has happened worldwide, including in India. Urban sprawl means low density, dispersed, single-use, single-person homes, and they are very much dependent. The built environment is built in such a way that it's dependent on car. If you have to move from one place to another, because there is segregation of workspace from living spaces and so on, and leads to lengthy travel, because if you have institutions at one place and residential areas another place, then you need to travel a lot. And there's also always a distinction of class and income. Certain places, some people can live, in other places, they cannot live because it's very expensive. And this again leads to long travel, especially for the poor. And urban form and travel are interconnected. Density influences the distance and the modes of travel, and spatial distribution of population, employment, and land cover, this all shape the spatial form. So, urban form influences travel, and travel influences urban form. Some examples here, monocentric cities. This is the old-fashioned model where we have a CBD in the center, and the arrows, the black arrows, show the dominant movement of people coming from other residential areas to the CBD for their work or for other purpose. And the polycentric cities, we have the central CBD also, but you have several other centers where commercial and residential and other means of work take place. So the prominent movement is shown by black arrows, and then there are interconnected movements also. The largest cities tend to be polycentric. This graph shows a distribution of trips for various Indian cities. It shows the density versus average trip. We can see in Kolkata, which is around 10,000 persons per square kilometer, the average trip length is around 11 kilometers. And it varies from city to city. Some of the cities have pretty long average trip lengths, which means there's a lot of travel required and a lot of money to be spent for travel. This graph is average trip length in the Indian cities as a function of total population. We see that Kolkata overall has a population of around 15 million, and the trip length is average 11 kilometers, as I already said. Now, urban densities and public transport threshold are related. If we have a city which is very spread out, then it is difficult to have a very efficient public transport system. Here is an example of Atlanta, which is multi-nucleated cities, and density is very low, so it's difficult to provide transit services there. But on the other end of the spectrum is Shanghai, where it's very highly compact and built. So it's easier to provide, and makes sense to provide good public transport. And several other cities are in between. So this graph is a representation of how public transports can be provided to various cities depending on their densities. In order to plan an accessible city, it is important to have a coordination between urban transport, land development, to have sustainable forms for the future. And the design layout of a city strongly influences how you travel. Compact cities and smart cities, we have heard these terms used a number of times. Compact city or the smart city development means to make the city more mixed use and more compact, so that resource can be used efficiently. Compact city is a term used mostly in Europe and Australia, and smart growth. Similar thing is used in North America. So what is a compact city? It is an antidote to sprawl. Where sprawl means growth in the outer area, compact city tries to make it in the central area, reverse of that. It aims to reduce municipal fiscal burden because we are providing the service in over a smaller area, not a very spread out area. And it can help in non-motorized travel by encouraging walking, cycling, and also preservation of historical areas, encourages mixed-use housing, and helps reduce the social and class segregation because various types of people can live close by, and takes away the bias for mobility choices. In sprawl, there's always a bias towards a car usage. But in compact city, that bias can be taken off. People can use various modes. They can have a choice of modes for travel. The principles of doing a compact city design are mixed-use planning, compact building designs, range of housing, neighborhoods to be made into walkable neighborhoods, distinctive, attractive communities with strong sense of a place, where people have that sense of belonging to a place. And then we have to have the preservation of open spaces, natural beauty, and critical environmental areas. These are all the principles of designing compact cities. And the development directed towards existing communities, you can have various choices of transport. You're just not dependent on your private cars. Development decisions can be taken in a more predictable, fair manner and by participation of various stakeholders. Some examples here of compact cities or planning for compact cities: Singapore, Stockholm, and Curitiba. We have heard about Curitiba. I'll talk a little bit more about it. They made a conscious decision to make an investment to shape the transportation, and that is how it has come up. Barcelona has a strategic plan where they have made a compact city form to preserve their city's legacy. And it is very user-friendly for walkers. People can walk very easily there. Distances are shorter, so it reduces the trip length and trip travel time. Having a high percentage of land allocated street is very important. But that's not the only condition. We have to have integrated mobility planning. And we have to look at the three layers. First, the local or the neighborhood level, then the intermediate level of the urban area or the district or a corridor, and then the larger, the region-wise. I'll briefly touch upon all these three. Some more examples. In Portland, Oregon, they have used the principle of smart growth, and they have certain growth limitation areas, and it's well planned for various modes of transport, and growth cannot go beyond certain boundaries so that the growth becomes inward than outwards. This is a good example of smart growth. And the built environments and travel at the neighborhood scale. First of all, you're looking at the neighborhood scale. There are 5 Ds for the built environment influencing the travel. First is the density. Density is the total number of people living in a fixed area. That influences travel. Diversity, that's the type of usage, land use, mix. Design, the elements like the network, the street environment, whether it's friendly for different types of users. And destination accessibility. This is the ease with which one can access whichever place they want to go to. And the other 2 Ds are distance to transit. This is the distance that you have to travel from your home to the transit station or from the transit station to your destination. All these Ds are important in influencing your design. And they're often co-dependent. Destination accessibility is by far the most important. If a transit system is to be successful, it has to have a good destination accessibility. And now isolated neighborhoods with poor accessibility leads to car usage. So if we have a dense neighborhood, it will lessen the dependence on car usage. Land use diversity, as we already know, that mixed land use can often shorten trips. And it can also help in sharing or carpooling or parking sharing, and can lead to usage in the non-peak times. And quality of walking environment is important. It's especially important for aged people, and is also gender sensitive in terms of security and safety. Various neighborhood designs and retrofits are used to reduce the need for travel by private car. And the new urbanism concept tries to bring in the concept of compact city. Now, so that it can be easily managed and transportation modes are multiple. Coming to transit-oriented development, we have already touched on this subject. I'll just briefly go over this. Transit-oriented development is development around a transit station. It is a new urbanism form where compactness is emphasized. It aims to make transit as a hub, the station as a hub, so that a lot of activities can take place around that transit station. And it refers to compact, mixed-use, pedestrian-friendly environment. And that particular station can be used for various other functions, for community functions. Some examples. In Scandinavia, they have made good TOD, and it has become a community's hub. It is a gathering place for public events, and TOD design can have significant benefits for the communities. Various benefits include increasing public transport ridership. If you have a compact built-up area, then you have good ridership. It can give you mobility choices in terms of transit or various other paratransit modes, increases the public safety, helps in reducing air pollution, energy consumption rates, and builds social capital in terms of increasing commerce, economic activities. This is this pictorial representation of a transit-oriented development. The focus is at the transit station. And then in the 650 meters or roughly 2,000 feet area. We have the commercial developments, we have the residential, office development, and slowly as you go away, you have the open spaces and residential areas, all easily walkable, and the access to the transit station is very important. And these are the various functions. The TOD it promotes sustainability, it stimulates local economies, it improves the public health. I won't go into details of each, but serves various purposes. Now the various components of a TOD, it has interconnected street network, non-motorized transport is encouraged. TOD combined with traffic calming measures like using the roads more for the commuters than for the cars. That helps in people safely using the roads. Then there's mixed land use I've talked about already. The intermodal integration in terms of modes, in terms of information, in terms of various other components, this integration is needed. And there's the concept of complete street, which is the word used nowadays, it's complete street, which is not meant for vehicles only, but also meant for pedestrians or other non-motorized people, transport. And there is a multimodal integration and first and last mile connectivities, which has already been talked about. There's a lot of TOD which has developed in Europe, particularly in Scandinavia. Copenhagen has famous finger plan example, and Stockholm has the necklace of pearl. I'll talk about it in a little while. In Latin America, TOD has been planned around busways or bus BRTs. That's in Curitiba, Brazil. We heard about it. That's also in Santiago and in Guatemala City. And in Asia, we have several TODs. Mostly in China, and there's in Malaysia also, and in India also we are working on TODs. Along with the TODs, the concept of traffic calming and car restricted neighborhood comes in, which helps the TOD. In many European cities, we have the pedestrian only areas or pedestrian safe areas, which is a part of transport planning. And traffic calming was first pioneered by Dutch planners, which basically means reduce high-speed usage of cars through the residential areas. And this is by building in design in such a way that less usage of cars are possible, and even if they're going through, they drive at lesser speed. With traffic calming, street becomes more of a neighborhood area. People can use it for various purposes, not just to drive through. And the next step is
10 minutes
totally...
more.
Okay. The next step is car-free areas. Several cities have tried this in their central areas, where for certain blocks, cars are not allowed. Because originally the European cities were designed with narrower roads before the automobiles came about, and now some of the areas are becoming car-free. The examples are in Athens and several in Spain, in Germany, in Italy, Netherlands, and also in Oxford and Cambridge in the university area, they have car-free areas. And there's pedestrian areas and shopping areas have come up in Copenhagen, in Portugal, and also in Stockholm. And then the concept of, I'll talk a little bit about the Curitiba example, where, okay, I'll come to it a little later on when I talk about the corridor aspect. Now, after we talked about the neighborhood level planning, we now go to corridor. A corridor is a transportation corridor which connects various activity centers. Various cities or activity centers can be connected by one line. That is a transportation corridors. This represents special contexts, and significant challenges also exist. Because the question comes in, if you have a high-speed mass transport corridor and you cannot give too much of access to it, cannot have too many stations or too many stops. But again, if you do not have too many stops, then your usage, ridership can also go down. So we have to have a balance between the two. Corridors present a special context while designing the TODs, and this function to move people and goods can often lead to intense development pressure, and can later again stop your mobility functions also. So we have to be careful while planning that. Public transport-oriented corridors have been developed in various cities. Here, one example I'm giving here, two examples in Stockholm and Helsinki. And the most well-known example is the Necklace of Pearl, which I'll show in a minute, which is the various transit lines and which activity centers developed around it. Looks like a necklace of pearl. This has been done in Stockholm. I'll show you the example here. These are the black circles are the established developments, and you have the connections by transit. This is a often quoted example. And going into the Curitiba example, I'll go to this figure instead of talking about it. There's one main spine where high-speed BRTs ply, and then you have the secondary and tertiary levels of roads. And you have the zoning systems where in the first level, you have the very high density growth with commercial and office usage, and then the residential usage. And this has been practiced and successfully in Curitiba. Now going into the regional concept, moving off from the corridor to the regional, we have various large agglomerations of urban areas. These are either mega regions or urban corridors or various city areas. And connectivity for all this thing is very important to connect these mega regions. Some examples in some cities, Cairo, in Mexico City, in Bangalore, we have a huge mega system, a mega area for transport of urban development coming up. Similarly, in Mumbai, Delhi, we have large areas which have to be given proper connectivity in terms of transport. In China, in Guangdong province, they have a huge Pearl River Delta mega region which is coming up. Each has a conglomeration of 9 large cities, which is about 40,000 square kilometers of area, and with impressive transport infrastructure linkages. This is large economical prosperous cities like Shanghai and Guangzhou have invested in lot in transport infrastructure to connect the peripheral towns. Large urban configurations amplify the benefits of economies of scale. Now this is an example of Pearl River Delta. You can see the 9 cities over a very large area, and these are all connected by high-speed transit. And Guangdong provincial government has announced it is planning to create world's biggest mega city. And it would have large portion of the population and economic activity there. 9 cities would be a part of this mega city. In Europe, large urban configurations are either along a major transport corridor or along the coast or along the coastal integrated area. They have multiple types of transport. They're all interlinked. They have the land transport by road, by rail, and also the sea transport and air transport, all linked together. And there's a large network of trans-European transport network which promotes sustainable mobility. In North America, cities have traditionally been around the highways and the freeways. Typical morphology is a polycentric development of cities. And most original American cities had the CBD, but it has developed into various modes. Polycentric developments have happened. The Washington, D.C. area is an example where it's not only the D.C. area, but the area of Maryland and Virginia also all connected. And they're connected by the Beltway and also by the various freeways which connect it. It's mostly road-driven development. Similar is example in Dallas, San Francisco, and Los Angeles and Chicago areas also. In Asia, we have very dispersed growth, both in South Asia, Southeastern Asia. The city development has happened in a not very planned manner, and the connectivities are not very good. So it's very difficult for people, especially the poor people, to travel long distances to go to their work. Manila, Delhi, Kuala Lumpur have well-developed sub-metropolitan centers for development, of employment, where people go to work. These include commercial areas and large export enterprise zones. However, the interlinkings are not very good in terms of transport. Africa doesn't have that much of large urban configurations, but some of the major cities which are growing very fast are Lagos, Cairo, Kinshasa, Johannesburg, and Nairobi, and where transportation connectivities are an issue. So coming to the impacts of transportation investment shapes the urban form. It is necessary, but transportation is necessary, but not sufficient precondition for land use changes. Urban rail systems are potential city shapers. Often rail-based transport investments end up being a strong force towards decentralization than concentration. Because if you have a very good railway line connecting the central part with the suburbs, people a lot of times tend to move outside. This graph shows urban transport investment in an urban form. We can see that CBD x-axis shows the distance from CBD and the density is on the y-axis. Now, in the time which before the rail, most of the development were around the CBD or close distances. But with time, as the transportation improved, you had several sub-centers because of the railway centers, the railway points. And then decentralization happened and people moved up further. Examples in Toronto and Munich, here the regional government help in TOD processes with a combination of regulations and incentive-based policies. Rail systems in these cities have attracted significant share of new development.
Sir, 3 minutes.
Okay, I'll be done very soon. There are some prerequisites. I'll be going very quickly. Proactive planning is necessary. This is, if decentralized growth is to take form of sub-centers, then we need to have railways and busways can spur central city redevelopment. And for that, government needs to take a role of trying to redevelop the area. Examples are there in Tokyo, in Hong Kong, London, and San Francisco Bay Area. Other pro-development measures must accompany public transport investments. And there are some measures like permissive and incentive zoning, availability of near vacant land, these are necessary. Measures to support land use and transport changes, complementary public involvement, and absence of physical constraints. And public transport services and incentives and private sector, okay. Apart from providing public services, we also have to disincentivize the private transport. Because if we provide good parking areas and also expect that people will be using public transport, then that will not be going to be successful. And congestion pricing has been used in several cities. Singapore is very well known, also Stockholm and London, which uses congestion pricing as a disincentive for car users. Network effects matter. If you have a good network of transportation in terms of railways or BRTs, then people will use the TOD more. And the cities which have a very strong public transport based network, they are, because railways shares a majority of the origin and destination, either be it BRT or railways. And in conclusion, we can say transportation and land use integration is very important. And other benefits from this are the social inclusion, growth, municipal cost savings, to create more accessible, livable, and less car-dependent cities of the future. Thank you. And you can get this from this reference, this book. Thank you.
Thank you, sir. That was quite insightful. And last but not the least, panelist is Dr. Krishnanu Shatra, Assistant Professor, Architecture and Planning, IST Shibpur. He completed his Bachelor of Architecture from Jadavpur University, India in 2010, received the Master of City Planning degree with honors in Urban Planning with specialization in Land Use Infrastructure Planning from IIT Kharagpur. In 2012, received PhD degree from IIT Kharagpur in 2020 with specialization in Urban Informatics, Public Transportation Optimization and Transportation Planning. তাড়াতাড়ি দেখে দিন। While he is setting up the projector, can we have a part of panel discussion started a little bit? Because students, you have any question for the panel? Okay.
Good afternoon. Sir, my question is regarding TOD. So, whenever we have TOD development, as we know that the land prices increase near the TOD zones. And as a result, when builders are asked to make housing, it's meant for the HIG groups because of the land value. And HIG groups don't really need, I mean, they don't really prefer the public transport. As a result, the LIG and the MIG groups are pushed further away. So in this kind of a scenario, is TOD actually helping the ones who really need it, or is it actually helping the builders and for land monetization? So, sir, what's your take on that?
I'll answer this question once this is over, okay? So that as a whole panel we can give this answer.
Okay.
Hello.
Hello, yes, you can start now.
Okay. First of all, I would like to thank you, the organizing body, and of course, Paulamidi, for this invitation. And I would also like to thank you, two of my previous speakers. And a good evening to everybody. So this particular session is been revised for the previous two sessions, previous two presentation actually. So I would like to point out that this session is not going to be very long. It's quite a comprehensive thing you have already listened to. So it's just the pointing out that from academia, how we perceive this particular problem of transit urbanism, which is called. So, and under the light of this rise. So that's my focus will be. So firstly, the rise is basically that it should be, its definition is already been talked about very elaborately so far. So the key principles I would be like to talk about, that robustness, redundancy, flexibility and equity that my respected speaker has already talked about, which I will come in connection, with this connection, I will come to this in later part of my presentation. So this is the key principles of RISE. Then the need of the resilient urban mobility within our context of Indian context, basically. So the key aspects will be the sustainable mobility, the multimodal systems, and TOD. Exactly what already has been pointed out. So The sustainable mobility, as you have understood, that it's is designing the mobility systems that continue to function, adapt, and recover under shocks. So I will come to these shocks afterwards. Multimodal systems, which is a transport system that can survive failures, absorb shocks, recognize itself in various other difficult conditions, and still functioning under certain stress itself. So it's, you can say for our country, it's like the stress would be the population, the demand actually. So our multimodal system for Indian context would require a good amount of capacity handling capabilities. So in terms of the TOD, you have seen the elaborative case studies from my previous speaker that the TOD is essential and it has already been under practice in the various other countries of our world. So why this rise matters in urban mobility is our concern. That is the urbanization pressures and rapid growth in the city that we will actually start facing at this point. And for the future planners and future architects, so you will be also under the same context. So since this responsibility is upon all of us, so we will be focusing on urbanization, which requires an adaptive infrastructure. We will look forward to that can absorb shocks like climate events, pandemics. We have also seen the pandemics, and the economic changes or economic downfall is also one of the major concerns what we will look forward to, while maintaining the functionality. So our urbanization is required, the future urban spaces will require all of these resilience to all of these aspects. So connecting to that, the mobility systems are the frontiers in development in future. So this is contextual to that respect. Then this further, the slides will be under these conditions. So already with these three salient points have been talked about, but my slides are little bit towards the expressing the need of the academia into these particular aspects, pertinent aspects that my previous speakers has already been highlighted. So the sustainable urban mobility is the primary concern that we already have discussed, that which reduces the emissions, enhance inclusivity, and which while maintaining the service levels during the disruptions as well. So this sustainable mobility has been talked about in in various other contexts, but in academia it's defined as or its goal rather been discussed in the form of the acceleration and extension of the access to safe, reliable and comfortable mobility for all, while having a zero traffic accidents, low environmental impacts, affordability and reduced demands on energy and time. So the core principles are minimizing environmental impacts, promoting social equity, affordability and increasing accessibility itself. So the key components or key tools to execute all these things are the public transit systems that you have already came to know. So the non-motorized modes like the active transits that we call nowadays, which are the walking, cycling, etc. And there is also the electric and the other hybrid fleets that are there, slowly coming into this scenario, are also the key aspects to look for the future to manage this demand that I was talking about. So the policy framework that prioritizes people over private cars is one of the primary concern. So this being said, the sustainable mobility, the scope and dimensions are pretty dynamic. So the key difference from the conventional planning approach in transportation could be like this, that the conventional planning focuses on physical dimensions of or the infrastructure in terms of mobility and the resulting traffic, while the sustainable mobility approach primarily considers the social dimensions in terms of accessibility and people, either in or the vehicle or like for the pedestrians itself. So coming next to this components, that the key indicators in academia that we look forward to in this context are it should be specific, the indicator should be complete to cover the various impact of the sustainability aspects. It should be measurable, it should be sensitive to the various other changes associated with it, and it should be technology neutral, and it should be scalable. So there are 22 aspects associated with it. So you can, the names are like listed over here, so, and the definitions are also given. So the emissions of greenhouse gases are the primary one that we all like familiar with. So we measured this, I will try to elaborate that only. So the rest of the things are falling on the same bucket. So the emissions of greenhouse gases are one of the concerns that it has been estimated in terms of the total emission of greenhouse gas by the whole city mobility system for a given period of time. So, or the study year. So that is the concept for one parameter itself. And similarly for the other 21 parameters rather, so it could be studied and the indicators could be estimated based on its own merit for each of the study areas. So, and after that, so, and there are many of them, so I will name a few, like net public finance, congestion and delays that we usually face every day, so that is also quantifiable, and that we can compare from, based on that indicator, we can compare one city to the other. So the academia is basically more interested in finding those conclusions from, while you are dealing with one city and what is the condition of other cities with respect to that. So as my previous speaker has pointed out, that many of those case studies, successful case studies, or many of those case studies which are also there readily available, which are also showing that the improvement or the gaps are still there, where we can intervene as a transport planner or future transport planner onto this particular context. And since the developing country like India having a scope or having a significant amount of gaps in improving the transportation systems with respect to the other developed countries, so we have this enormous scope for you to contribute. So coming to this other parameters like commuting travel times, mobility space usage, and then quality of public area, access to mobility services, traffic safety, noise hindrance, air polluting emissions, comfort and pleasure. So it's like it's comfort and convenience for the transport is measurable nowadays. So and the parameter is pretty significant because we all looking forward to AC bus services over the conventional bus services once the summer arrives. So the comfort and convenience in public transport is one of the primary concerns, that we avoid such and such services where the AC is not available. So so this is one of the determinants. So similarly, there are accessibility for mobility impaired groups. So accessibility for all is another concern, where we want our systems to be, readily available for everybody. So, or the impaired groups as well. So that being said, there are affordability of public transport as well that should be, affordable for everybody. There are security aspects, there are functional diversity, there are intermodal connectivity, there are intermodal integration as well. And similarly, there are resilience for disaster and ecological and social disruptions. So as we have talked about pandemic many of the times, or since you have seen the pandemic, that during that time, the transport was the primary thing that we have shut down. So during that time as well, so how it can cope up in future. So it should not be happening in future as well. That our primary concern. So in case of such occurrences, so how transport react to it is also our, that comes also within our scope itself. So similarly, lastly, the occupancy rate, the opportunity for active mobility and energy efficiency are the primary indicators that comes under the the sustainable mobility umbrella. So these are only reported indicators. There are a lot of scopes to further explore this possibility of what could explain the sustainability in terms of the in academics. So this could be one of the only one part of it as a consolidated study you can consider. So as a summary, I can say that the resulting indicators can be applied for various several purposes, as I have said earlier, for self-evaluation of a city's mobility system, as I was talking about, to compare, to monitor, to to assess the policies, to benchmark with other cities, as my previous speakers has already pointed out to few of those case studies. So you can also take as a benchmark and compare our city or any other cities, what is also could be done through this. So with this, finally the intermodal connectivity and intermodal integration has also been proposed for in various published literature, where the considerations are these parameters: the volume of passengers and activities, the number of interfacing routes, the number of interfacing modes. So all these comes under very much into the into the literature. So that I could report from the academic point of view, and the concluding remark could be the in contemporary urban planning, the sustainable mobility is no longer only an environmental agenda. It has become a core strategy for building resilient cities capable of surviving, adapting, and growing under uncertainty. So the future is uncertain in certain respects. So the transit needs to be one of those concerns that can make the city resilient for the future context. Moving on to the multimodal systems, as it has been also elaborately discussed, I will try to keep it short and try to report that what is going on in academia and what are the primary concerns about it in the state-of-art studies. So the multimodal system is like the nervous system of a resilient city that that has been also been told. The network redundancy, the mobility as a service, which is called MaaS, as you have also heard. The last mile connectivity, which has also been discussed. And now moving to the core principles and key components of this multimodal systems. So the public transit system is one of the primary aspects of this. The non-motorized modes, the walking and cycling, the set of passenger-related data could be combined. So here comes the, the big data kind of studies where we collect all the...
10 minutes.
Sure. So it won't take that much as well. So the thing is that once the data or the observations are coming in from the real life, so we can store it, we can process it, and we can utilize it for the further assessment and to make our future more livable. So that is the simplest way I can describe what is going on in this within this state-of-art practices. So the principle of equality and human rights with respect to access to public services. So that is the one of the key components. The key reference concept is the inclusive design that been already said, and the user with specific needs are also need to be taken care of. So this being said, so the digital interface usability, as I was talking about, the observations and assessment of the real life could be done through IoTs, various other sensors, and the big data could be processed through the analytics, as my previous speaker has already pointed out. So these are and to find out the characteristics of the entity or the study area. So, and based on that, the policies are to be formulated and implemented for the better future. So that the two components out of these comes as a passenger characterization, which is like passengers deal with a number of variables when planning door-to-door intermodal travels. You also take the similar kind of decisions once coming into your institute. So there may be some disruptions once you choose the other kind of modes. So these modes need to be readily available to your options. And this is basically all the modes coming together as an option to you comes as a multimodal system, which we define. So so this is one of the primary concerns for the users. So each variable can differ according to the specific passenger profile, so that you also one of those, me being one of those users as well of the, this one of these multimodal systems. So we take decisions based on our choices on with various other considerations. So each characteristic of a passenger profile contribute to the specific needs of expectations to be matched. And then finally the mobility is, and requiring that the mobility service as a whole provides specific tangible or intangible features. So it's basically that all the options should be available to all the users. And similarly, the goal of this multimodal system could be successfully implemented. So moving on, so there are various other components as well. So since I should not be elaborating much about this, these are all available in the academic publications. So the key variables again are listed over here for your consideration. So this any of these could be all of these could be analyzed, assessed, and then it could be reported in form of in the academia itself. So so these are the pretty much contextual thing within the state-of-art practices. So there are two type of travelers that we can point out at this point in theoretically. That is the business traveler or the work-based trips, and the other travelers like the non-work-based trips. So based on their characteristics and based on their choices of the users, you can like fine-tune the requirements of the mobility or the multimodal transit. If you are trying to plan it, you need to satisfy all the needs from different user groups. So the passenger-centered requirements for multimodal door-to-door journey, that the latest consideration you can have is like our Ola or Uber or the cab services, various other cab services that comes into as an option as well. So similar to that, as my previous speakers has already pointed out, that there will be last mile connectivity, there will be transit hubs, there will be various other options of like metros, bus services, BRTs. So all of these, if available to you, so you will be still choosing one of the convenient options based on your choices and affordability. So this comes as the passenger-centered requirements for multimodal door-to-door journey, which are actually listed over here. So these are the pre-trip, wayside, and onboard and post-trip kind of a scenario that that is listed in this particular chart. That based on what kind of requirements we choose, what kind of decisions we take, what kind of decisions. Okay, lastly, coming to this TOD, as it has been extensively discussed, I will keep it very short. So as it has been already been pointed out that there are several Ds that are considered in this context. So density, diversity, design, durability are the primary concerns. However, there are 6 Ds you can are actually in academia. There are 6 Ds has been reported. So within that, the 6D framework, the planning policies and implementation, the 6D framework is land use, also includes the land use and transportation. And the 6D framework in urban design are also been, in practice. So let me just tell you that what are the 6 Ds. That is, firstly is that I just recall from the earlier discussion as well. The density, diversity, design, are the primary three, and the destination, distance, and demand are the other three. So if we just get into this different study group as well, or different genre of study as well, there are also these 6Ds are being discussed in elaborative manner. Okay, so now the coming also in land development or land use studies, there are also sustainable developments. There are, and still after all this exploration, there are need for further investigation as well, which is theoretical investigation, particularly needed to assess from a normative standpoint. So which is comes as a policy framework. So creating this normative standpoint means it's like creating norms for certain development strategies. So this could be also taken for our Indian context, and it could be also reviewed the roles, responsibilities of the public and private sector. So it's the normative standpoint also comes as a responsibility for both the parties. Both the parties means the public sector as well as the private sectors. So, and there are these case studies which has already been talked about. So I won't be elaborating much about this. And finally, the conclusion and findings. So from three of these concepts or three of these buckets, you can, or one can summarize that mobility as a tool for resilient urban expansion is one of the primary concern. Multimodality and resilient integration is another consideration that the future transportation planner should be exploring, exploring much. So TOD and resilient urban development are the future for, more compact and livable, urban spaces. So that is the I thank you all with that, and that I conclude my presentation.
Now I will request the panelists to answer one of the.
I don't know.
Yes, now I'll request the panelists to answer the question that has been already asked by one of the participants.
I'll just take that question, frankly speaking. Now, to give that answer regarding the TOD in the transit node or the station, regarding the low-cost housing, why it is not, why it is difficult or why it is not being implemented. So in my presentation, I have told that there is a need for public-private participation, which is called the PPP. So this is one point. Now, why I am talking about that? Regarding these transit nodes or the station, these are the land which belongs to government. Now, this land, as it belongs to government, the development under this land, always the government is responsible. Now, I have also spoke about what kind of a development should be encouraged, or rather is encouraged as on today. It is the mixed commercial development, because that is the viability or viable option regarding the transit-oriented development in the transit nodes or within the station limit. So why not the residential? Yeah, residential can be possible if government takes the initiative. How it is possible? If you go and see Singapore, where we call, there is, apart from the station, the line, we call it as a viaduct. Okay. There is a terminology for it. And below the viaduct, government is developing or encouraging the mass level housing project over there, where as it is government by policy, there is a mixed kind of a horizon of commuters, or rather the public can basically come and take the housing from the HIG to the MIG to the LIG. So it is not happening, it is not like that. But in India, as we are not developed in that sense yet, so that is the need of the hour, is the PPP model or the public-private participation. However, saying that, till now it is being encouraged about the mixed use development, where the office space, the retail space, and other public entertainment zones are being encouraged to develop as a TOD.
Does that answer your question, Amrapali? Yeah, I think there's kind of a cross-subsidy model has been developed, which you earn from somewhere, you make some profit and give some towards the development. So, yes, anybody else? I think Intikab has had a question. Intikab?
Yes, ma'am, a very small question.
Okay, small question, please ask.
Yes, like sir was talking about mixed use development, but in terms of mixed use development also comes noise pollution. So how can we deal with that?
What exactly do you mean mixed use development brings in noise?
Actually, sir, mixed use development means commercial and residential in a same zone or same building. So commercial areas can create some noise which can affect the residential tenants or zones. So how can we deal the noise pollution that created by the commercial areas?
Okay. See, there's one part of it, we have certain development control rules also. We cannot have everything and anything built up, next to each other. So when we are talking of mixed use development, we are not talking about a factory right next to a building, or some kind of a commercial development which will create. Hello? Yeah, some kind of commercial development which will bring a lot of noise and other pollution level. So there also we are not talking about everything. So that there automatically some control comes in. Okay? You want to elaborate on that?
Okay, thank you, sir.
Yeah, and then have you heard of the term eye on the street? Mixed use development is always good for safety purposes. Now, anybody else? Or else I have two questions to the panelists, and after that we'll end. That is, one thing is, Amitabh talked about unified ticketing system. How in present scenario of Kolkata, where we have very rudimentary auto drivers, and then toto drivers, rickshawalas, and then our bus, then say tram, whatever, we have different modes here in Kolkata. And do you think in near future, I can't see in 50 years down the line, with this kind of mixed mode and with this kind of operating system, we can look forward to unified ticketing system, and with this amount of population, is it possible?
Very good question, very interesting question, at the same time very difficult question also. Now, unified ticketing system is that kind of a facility which provides the ticketing system across different modes of transport. I'm just coming to your point, Palome. Now, in Delhi, it is almost successful. Why? Because in Delhi, all the metros are being operated by one body, government body, that is called DMRC. But in Kolkata, the metros are being developed by different agencies. I'm not very sure that how basically you will take it. So one is the KMRCL, Kolkata Metro Rail Corporation Limited. Another body is Metro Rail Kolkata, under the direct control of Railway Board. Another is RVNL, Rail Vikas Nigam Limited. So there are different bodies basically which are working in West Bengal rather in Kolkata. There is different reason for that. There are some of the political, some of the non-political, whatever may be the reason. That is why in Kolkata, till now, it is getting very difficult to implement the unified ticketing system. And to the next point, apart from the metros, why it cannot be implemented into the railway? As I have already told you, that metro is a different body under the railway board. It is an autonomous body. So railway is now working for it to implement this unified ticketing system so that it is not only for the metro system, the same ticketing system can be implemented into the railway also, means local railway and the suburban railway. And in Kolkata, why it is difficult? Because in Kolkata, apart from the government buses, private buses also ply.
Lots of private players. Yes, that's what I was.
Private buses also ply where the unified ticketing system will be very difficult to implement. Not only that, as you have rightly highlighted, it is not only about the buses. Also, there are rickshaws and the other modes of transportation also in Kolkata. So Kolkata is a very difficult city in terms of implementing the unified ticketing system. Wherever other cities have a better prospect, better facilities in terms of implementing it. That is how it is right now. I am not very sure how basically the future will take it.
I think
Shubhendu,
India as a whole should have its own ecosystem of transport, because if we try to copy the West, there is no way we can match, because the whole scenario is different. The whole scenario on which you will plan is different in terms of modes, different in terms of population, different in terms of people's behavior. So it's no way we can bring in foreign examples and we can copy. We should have our own ecosystem, and we should start thinking as, since you all are transport planners sitting here, I would urge that we should start thinking from a different perspective other than copying models from outside, where India can fit in, because BRTS has failed largely in India. Other than Pune, where the population is very, very less, BRTS could not be implemented. I think nothing, TOD also will not work in India as far as my insight goes. TOD will work only if their new cities come up. And we don't do any wrong planning as Newton has been done. So in that case only, TOD might work in India. And but I don't see and most of the cities in India are very old cities, so it's very difficult in my perspective. Sir, your intake on that?
Okay, I'll come to this. The previous point, I just wanted to add one thing. You mentioned about unified ticketing. Yes, as he said, there's difficulty in coordination between various bodies. So it's an institutional issue. It's a legal issue, because how the money is going to be transferred from one agency to the other. But work is going on in making up a policy for that. And then secondly, the first is going to be between different agencies which run the transit organization. Then buses and other things will come in. It has to be layered system. It can't be all in same
All
place.
unified. So that's why I said it has the entire ecosystem has to be
there's a lot
different.
of
So
work needs to
there
be
can
done.
can't be same terminology also.
Yeah, but hopefully, things will be improving, because process has also started already in working on that.
Yeah, we can only be hopeful for India. Yes. You want to add anything? So if anybody else doesn't have any question, with that we'll end this session. Thank you, my panelists, for being here and patiently waiting for your session to start. We actually got a little late in starting the session. Thank you.
Thank you, respected session chair and all the dignitaries. So with this, we come to an end of day 1 of our symposium. So we all look forward to see you tomorrow at sharp 10 a.m. like today. In the meantime, we will end the day with the high tea. So tea is being served. So all of you can go and have your tea. Thank you. My name is Indranil and I'm signing off for today. Thank you. Bye-bye.